The introduction of antibiotics in animal feed has contributed exponentially to the antibiotic resistance crisis in the world today.
40 million prescriptions for antibiotics are issued each year in England. Experts warn this is creating new bacterial infections resistant to treatment.
We are seeing increasingly cases of TB where they have multi-drug resistance and are very difficult to treat. And there could be the possibility that in my old age I go for a hip replacement and get some infection and I can't be treated. That's not a nice future.
Antibiotics only became widely available after the Second World War, giving doctors a new weapon against deadly infections, one of the wonders of modern medicine.
In 1928, Alexander Fleming discovered the first antibiotic, penicillin. This was a revolutionary discovery at the time because infections were no longer life-threatening and could be prevented with antibiotics. However, we were warned that the more antibiotics we used, the less effective they would become.
No disease has killed more people in all of human history than tuberculosis. A frighteningly contagious disease, TB infected in the late 19th century more than 80%, yes, 80% of all Americans before their 20th birthday. And we didn't even get the worst of it. Infection rates were closer to 100% throughout Europe and elsewhere around the world, wherever people gathered in close quarters. Most of these infections were latent or asymptomatic, but they could activate at any time, at which point the disease would trigger a violent immune response that literally consumes the body from within. As far back as 460 BC, Hippocrates identified tuberculosis as the most widespread disease of his time. Far from prescribing treatment, however, the namesake of the Hippocratic Oath warned fellow doctors not to visit TB patients in the late stages of their disease, lest these doctors' professional reputations be damaged upon their patients' likely death. You see, until the 1940s, there was no effective treatment for TB. Indeed, society's only answer to the TB scourge was to weed out active TB sufferers from their midst, sending them off to so-called tuberculosis sanatoria, where they would be given as much fresh air as possible, but remain bedbound until their death or return to latency. All of us, I'm sure, would rather not think about the horror that diseases like tuberculosis wrought on countless previous generations. But we have to remember, because there's a chance those dark days may return. If the drugs that treat TB lose their effectiveness due to antibiotic resistance, there will be little that we can do to stop it from spreading once again, even in wealthy nations like the United States. Moreover, the threat of antibiotic resistance isn't limited to tuberculosis. Concerns over drug resistance have arisen in recent years for many diseases, everything from gonorrhea to hospital-acquired strains of staph, E. coli, and salmonella.
But now there's growing concern they're being overused, taken for minor illnesses or not taken properly.
It's a development which we're told could return medicine to the dark ages. The overuse of antibiotics is leading to an increase in drug-resistant strains of diseases such as TB and malaria, and too few new treatments are being developed to tackle them.
Just stand with your chin on the ledge there, that's it, your hands on your hips.
Any minute now, this man will know whether it's likely that he has TB.
There's your x-ray here, John.
He's come to the Find and Treat bus run by University College London Hospital.
Looks fine.
So he's clear, but increasingly the people coming aboard are not. And also growing in numbers are those with multi-drug resistant and extremely drug-resistant TB, where the antibiotics are simply not working.
These organisms are almost unmanageable in some cases because people have become resistant to so many of the drugs that are currently available. There's hardly anything left in the therapeutic pipeline to treat them with. Treatment for multi-drug resistant TB lasts a minimum of about 2 years, and for XDR TB it's an even longer course, 3 years or more.
It's not just TB, though, that's becoming resistant. An ever-increasing range of infections can no longer be treated.
Hands on your hips.
Yet it's 30 years since a new antibiotic has been developed. So today the Prime Minister announced a review into the economics of it. Why are there no new drugs coming on board, and how can we change that? And what goes on here on this bus goes to the very heart of what David Cameron is talking about today, the need to tackle the threat of resistance to antibiotics. And it's something, he says, that has to be done on a global level, that all countries need to become involved in this fight. As does Big Pharma, the drug companies, because as the Chief Medical Officer said today, there's more profit for them currently in statins or diabetes drugs which people take for years, rather than in a short course of penicillin.
You can explain it in many ways. They don't make a big profit because, you know, it's not like a statin which you take every day. It's not like a diabetes drug you take every day, or a cancer drug where you get a lot of money, thousands of pounds for it. We take antibiotics for a week or two and we pay very little. But at the other end of the problem is we've disinvested across the world as governments and research funders in universities and institutes on the fundamental research. We're not doing enough research in infections as to what makes the bugs tick.
At last month's G7, the Prime Minister spoke privately to the other heads of state about the issue. He wants there to be coordinated action, because this is an international problem. Take TB. 1/5 of cases in Eastern Europe, Russia and Central Asia no longer responds to the standard treatment. Malaria drug resistance is especially bad in Cambodia, Burma, Thailand and Vietnam. And here in the UK, gonorrhea is becoming so resistant to drugs that doctors are being forced to switch to other treatments. GPs were once blamed for writing too many antibiotic prescriptions. That has now improved, though patients are still taking some persuading. But without change, the World Health Organization says we are approaching a post-antibiotic era in which common infections will kill.
We've been warned about the rise of superbugs for more than 20 years. We either act now or face a frightening future. Antibiotics delivered one of the great breakthroughs in medical history. We're now at risk of blowing it. It's a sobering thought, or should be, that every time we take an antibiotic, we're giving the bug we're trying to kill a chance to do the opposite, become a superbug. That chance increases if we don't complete the prescribed course of treatment. Already there are horror stories of what mayhem and suffering superbugs are capable of inflicting. It's a process of bacterial resistance that began with the very first use of penicillin. That was okay up to a point, for as long as scientists and drug companies continued to find new antibiotics to replace the ones for which bugs had developed a resistance. But now the tide has turned in favour of the bugs for various reasons. As a result, some superbugs have evolved that are so powerful they're capable of defeating every antibiotic available. We now face the grim prospect of a return to the pre-antibiotic era, when often the only way to defeat infection was to remove it surgically.
The human race has always been at war with bacteria. But the development of antibiotics in the 1930s and 40s gave us the upper hand over the bugs that were killing us. Suddenly, we were superhuman.
Prior to that, they were used to bacterial meningitis, 100% mortality. Bad pneumonia, 30% mortality. Appendicitis or ruptured bowel, 100% mortality, unless you had surgery. The only cure really was surgical intervention to cut the infection out.
Antibiotics allowed us to do things that no one could have dreamed of doing historically. They've allowed us to transplant organs. They've allowed us to undergo chemotherapy. They've allowed us to receive therapy in intensive care units when we're critically ill. Without antibiotics, none of those advances in human medicine would be possible.
We've still got the upper edge. Clearly, antibiotics still work, but it's the speed of change that concerns me. 20 years ago, this wasn't an issue. Today, it's a real issue. You know, infectious disease kills more people than cancer. TB kills 5,000 people a day. So if we don't start to act soon, start to put our pedal on the gas pretty soon, within another 20 years, we could be in serious trouble.
We've deployed our antibiotic defences far and wide, while the bacteria have kept up their counter-attack. They adapted and evolved. Now even our last precious antibiotics are surrendering to the rise of the superbugs.
I was feeling good. No problem, no symptoms, no nothing. I was feeling really great.
As his 60th birthday approached, Joel Becklew was feeling fit and enjoying semi-retirement. His career in Australia as a stage technician was winding down in favour of travel through Europe and spending a year in Bali with his partner, Roseanne Schock. During a brief return to Australia, he thought he'd better get a checkup.
Getting 60, you think better to have a good checkup. So I went to the doctor, and among the checkup was the prostate checkup, and feel a hard lamp there and say you better to go to urology. And I went to urology and they say, oh, you better to have a biopsy done.
It's a procedure undertaken by tens of thousands of Australian men every year. A special device passes a thin needle through the wall of the rectum to take a prostate sample. To prevent infection, antibiotics are taken. It's usually over within an hour.
The procedure was on Friday morning. By Saturday to Sunday night, 2 o'clock, that's when I started to shiver, and so I thought, okay, well, I've got the infection, better to go to the hospital. We took the ambulance to the hospital and discovered that the preventive antibiotic didn't work, and infection was spreading in my body.
The infection spread from Joel's prostate to his shoulder, spine and hip.
The first pain was in the collarbone. That was the very first one I noticed. Then the lower back pain started to come, and the hip, right in the hip joint, very, very strong pain. The pain was really horrible.
Standard antibiotics had no effect. Joel had a superbug.
I think within 10 days, the pain in my collarbone was so bad that they decided to operate to do a scraping of the abscess in the collarbone. And then I basically lost touch with reality for about a month because of the painkillers.
Joel spent 3 months in a hospital bed on rare antibiotics imported from overseas. His body wasted away. Now he's trying to regain his strength while fighting off the last of the infection.
Obviously, it has been a progress because I'm standing up and I can talk to you and whatever, which I wouldn't have been able to do only a month ago. A month ago, I was in pain and screaming in my bed, so it has been a big progress.
Somewhere in his travels, Joel had consumed a virulent strain of E. coli bacteria. It survived harmlessly inside his gut until it was unleashed by the prostate procedure.
This one's not too bad.
No, you're looking right there. I knew that it was a strain of E. coli they hadn't dealt with before, and that they were trying their very best to try and find something that it would respond to and that would have an effect. But I wasn't sure at times whether it was going to work or that his organs would cope with the bacteria and the antibiotics and everything else, and that he would come through it actually.
Did you fear for his life?
Yes, at times I didn't know that he was going to make it or not.
Now we know that people who've returned from overseas, in some of these hot spots where resistance is very common, and it's in the food supply and it's in the water supply because of misuse of antibiotics, mostly in those countries, that we've had a whole string of men after their prostate biopsy now getting superbugs into their bloodstream because we've introduced it into their prostate not knowingly, and it's then spread into their blood, and then they've got incredibly sick.
With 1 billion people now travelling the world each year, bacteria are more mobile than ever before.
And so are superbugs. They're born when we abuse antibiotics, and we're doing that across the globe.
Every time we take an antibiotic, we're giving the bug a chance to become a superbug. So if you think about you and the community, you know, the more of us that take antibiotics inappropriately, the greater the chances in the community a superbug will come.
Australia, I think, out in the community is pretty bad. It rates 7th in the world for overuse of antibiotics per capita. Australia is like many of the other developed countries. We saw development and wealth equaling ability to use antibiotics, and we lost the plot in terms of realising, well, most sore throats are due to viruses. They're not going to respond to antibiotics, but I want my antibiotics, you know.
It's the Indian subcontinent which is proving to be a superbug's perfect petri dish. Antibiotic abuse is rampant here.
In India, antibiotic overuse is a serious problem. There's no antibiotic policy in the country. But of course, there are many countries where there is no antibiotic policy. But I'm concerned about my country, and there is no antibiotic policy.
India mass produces antibiotics and sells them cheaply. The drugs are available over the counter without prescription. Waterways and even the soil are contaminated by waste from antibiotic manufacture. On top of poor sanitation and chronic overcrowding, it's fertile ground for antibiotic resistance.
There is a general principle in treatment of infections. The more we use any antibiotic, the quicker the bacteria are going to become resistant to it. So if we have a situation where antibiotics are used in agriculture, where they're available over the counter, where in hospitals there's very little control over their use, clearly in that environment there's going to be a more rapid spread of resistance.
When more and more patients in Indian hospitals began dying from untreatable infections, local microbiologists began to ask why. Working with international researchers, they identified one of the most dangerous superbugs the world has ever seen. They called it New Delhi metallobeta lactamase, or NDM1. It's a gene that can turn bacteria, once easily destroyed, into untreatable killers.
The NDM bug is really scary because you only have to drink 1 or 2 of those bugs, and they don't have to multiply in themselves. They just have to spit out the little bits of genetic material that make them superbugs, and then they convert all your healthy bacteria into superbugs. So it's a bit like putting a red T-shirt into the washing machine of white shirts. And the T-shirt itself doesn't have to multiply, it just has to leach out this stain, and it changes all your white shirts into red shirts and converts them into, you know, a superbug.
India's researchers were shunned at home for bringing the country into disrepute and threatening a multi-billion-dollar medical tourism industry. Chennai-based Dr. Abdul Ghafoor is one of the few Indian doctors prepared to speak out.
We need wartime measures. We can't wait and watch. What we need urgent wartime measures to rationalize the antibiotic in all countries. Government should take initiative and ask the medical community to use the antibiotics very sensibly. Government should bring in strict laws to rationalize the antibiotics in countries. There must be strict antibiotic policies on one end. On the other end, government should talk to pharma industries to stimulate the research on antibiotics.
The drugs that they were treating me with seemed worse than the infection. Because the infection, I didn't even know it was there unless they told me. But apparently it was so dangerous that they had to go to that extreme levels of treatment.
David Ricci travelled to India last year to volunteer in the slums of Calcutta. A walk to an orphanage one morning changed his life forever.
Me and my group kind of stayed like a single file line, and I was in the back of it. And so we didn't hear the train coming, and it like hooked my right sleeve and kind of threw me in front of the train and hit me and ran me over, and my leg got caught under the wheel. So I'm directly underneath the train, kind of head first. And it pulled me probably about 30 meters or so before it stopped. They had to back the train back over my leg because it was kind of stuck up in the wheels, kind of. And they pulled me out, and something punctured like my lower abdominal region, and it was probably about, yay long. And there's a lot of internal bleeding, and my femoral artery in my thigh started spraying and gushing blood all over me and stuff, and I was in shock, obviously, instantly.
Miraculously, a passerby managed to stop the bleeding. David Ricci was bundled into a cycle rickshaw and taken to a local clinic.
They started just putting water all over my leg and just kind of washing off all the dirt and the filth. Because when they pulled me out of the train, they set me in the trash because that was kind of the only place not on the tracks that they could put me. And so, I was just covered in filth and this black gunk all over me. And so they were washing all that off, and then he took out like a big leather bundle of knives and untied it and pulled out like a big medical knife and just started cutting my leg off.
David was in so much pain those first few days that he didn't want to live. Within a few weeks, he was in a hospital back in the United States.
It's so good.
Blood tests confirmed he still faced a danger even greater than being hit by a train and losing his leg.
A couple days later, they came in, all suited up, and they're like, sorry, we kind of need to quarantine you because you have a lot of dangerous infections that we haven't seen before, and we need to figure out how to treat this before you can do anything else.
David was infected with several types of NDM1 bacteria.
So what's happened with NDM1 is this particular gene has been able to jump around very, very quickly. It likes to get out and about, if you like. So it's jumped from one bacteria to another. It's jumped from one country to another very, very quickly. And that's why it's quite a dangerous bug, the NDM1 gene that's in all these different bacteria. The other key thing, of course, is there's only really one antibiotic left now that can kill this NDM1.
To date, Australia has dealt with fewer than 10 cases of infection by NDM1 type bacteria. The superbug is kept inside tightly secured laboratories, like this one at the University of Queensland.
When you look at one of the superbugs, it's the same type of bacteria, but this one has acquired those genes, the NDM1 gene. What you can see now is these powerful antibiotics that were being used before just aren't working at all. The bacteria is just ignoring them and growing quite happily in the presence of the antibiotic. The one in the middle here is the only one we've got left, that antibiotic called colistin, which can kill this particular superbug.
So will this superbug eventually defeat that antibiotic too?
Yes, it will. We haven't seen that in Australia yet, but overseas there are some cases where this particular bacterium is resistant to all antibiotics, including this one in the middle.
So you're only really buying some time?
Yes, we are.
Colistin was the only drug that worked for David Ricci. It was abandoned decades ago because it was too toxic.
I was only able to be on it for so long before my kidneys and my white blood cell count and everything started dropping. And they had to pull me off right before most of my organs were unretainable. And so at that point, they figured that it had worked because they didn't see any signs of infection. There was no fever, no irritation around the site. And so they figured that, well, I guess the infection's gone. But they left a track open in my leg, which we cleaned out every day, and it was just causing extreme pain. Like it was worse than India. It was, a 10 out of 10 pain, and I was just scream every single morning.
You would just see every day he would just go downhill and very pale and lethargic, and at times I felt like I was losing him, but it was from the antibiotics, and they didn't even know if they were going to work. So it was a hard time, a really hard time.
And, my doctors were like, all right, he shouldn't still be in this much pain. What's going on in there? So they surgically went in and looked, and it was all black and infected. So they're like, oh, well, it's back.
The tenacity of infections like NDM1 threaten not only individuals, but the very future of modern medicine.
I think the worst nightmare for a hospital would be that not only is there an outbreak of these particular infections, but they become entrenched. They're an ongoing problem for decades to come. That really changes the whole game in terms of ability to deliver high-quality medical services, to deliver transplantation or chemotherapy or intensive care medicine.
Melbourne's Austin Hospital faced this challenge last year when it agreed to accept a patient infected with a superbug. Nick Chameleonis picked it up while holidaying in his native Greece.
I've been the last 5 years 3 times to Greece. I have beautiful time, beautiful country for holiday, nice weather. I enjoy myself 80 days. The last 10 days, I come sick.
Nick ruptured his bowel and required urgent surgery. He was soon overcome by infection.
I feel tight, outside 38, 40 degrees, hot. I like to put me 5, 10 blankets.
In the end, he was in hospital in Greece for 6 months, 3 different hospitals, multiple operations to save his life, and ended up with lots of abscesses inside his abdomen, but was finally stable enough. I mean, Nick he's a tough nut, you know, and he was well enough to get airlifted back to Australia. We knew that he had these superbugs in his bowel, but also in all these abscesses. Essentially, they were untreatable.
At the Austin, Nick was kept in strict isolation.
There was precaution taken, and it was a harsh time for the family. Dad was quite, isolated and was in quarantine for the length of time he did stay at Austin, which the family felt, we felt for him.
Doctors struggled to find a combination of antibiotics which could kill Nick's superbug without killing Nick. Just like MDM1, this superbug was sharing its antibiotic-resistant gene with other bacteria.
Now, what's interesting is this is a strain also from the patient, and this is a different bug. It's called an E. coli, and previously this was sensitive. And you can see in this case that it's also growing quite well. I'll just carefully look. You can see it's pink though.
And that agar is full of antibiotics as well?
Full of antibiotics.
It's become a superbug.
So what's happened is that this Klebsiella strain has transferred its resistance gene to normally sensitive E. coli and turned this into a superbug, and this is from the same patient.
In the end, the infection could not be stopped. The only cure available was from a time when antibiotics did not exist. Nick's bowel was removed.
We were still not able to get on top of all his abscesses. And so in the end, there was a long discussion with the surgeons to say, look, maybe we should go back to the pre-antibiotic way of doing things and just cut it all out. In the end, we said to him, look, there's a 50% chance you're going to die on the table, on the operating table. If you don't have the surgery, you're dying in pieces. And my view was that he had maybe a 3% chance of living for another 6 months. And this was just for him, let alone all the risk to the greater community, you know. So essentially we had to take a pre-1940s approach to cure him. But that's an example of where we're headed. Unless we do something about this, there'll be more of him for sure.
They do the measure, now I feel like before. Exactly. I can tell you more better. Now I don't feel nothing. I do everything. I see the doctor sometime hospital. I can say thanks, saved my life.
You know, it can happen to anyone. It happened to my dad, certainly can happen to anyone that travels or that's away from home. And yeah, it is a scary thing. And if surgery wasn't an option, then we'd have nothing. And we wouldn't have my father today. So it's a worry and it's scary, yeah.
In 2010, the House Commerce Subcommittee on Health held a hearing on the threat of antimicrobial resistance. Director of the National Institute of Allergy and Infectious Diseases, Dr. Anthony Fauci, was questioned by Representative John Dingell on whether or not antibiotics in animal feed that isn't regulated poses a threat to our health.
Here's the purpose for my question. If we're putting too much in the animal feed, not using it wisely, and don't have any particular constraints on its use, we're obviously increasing a risk if a risk there is. Is that right? Clearly the answer to that's yes.
Antimicrobial agents represent one of the main therapeutic tools both in human and veterinary medicine to control and treat a variety of bacterial infectious diseases. However, during the past 5 decades, the use and sometimes misuse of antimicrobials in both human and veterinary medicine has resulted in the emergence of strains of bacteria that no longer respond to antimicrobial therapy. Not only do antimicrobial resistant bacterial pathogens in animals pose a risk in terms of animal health, they also affect public health when transmitted to humans as foodborne contaminants. Thus, addressing the issue of antimicrobial resistance is one of the most urgent priorities in the fields of public health today. The following animations will help illustrate several mechanisms where bacteria develop resistance to antimicrobial agents and then transfer this resistance to susceptible bacterial strains. Selection pressure. The increased prevalence and dissemination of resistance is an outcome of natural selection and should be viewed as an expected phenomenon of the Darwinian biological principle of survival of the fittest. In any large population of bacteria, a few cells will be present which possess traits that enable them to survive in the presence of a noxious substance. In this case, the ability to fend off the action of the antimicrobial. Susceptible organisms, those lacking the advantageous trait, will be eliminated, leaving the remaining resistant populations behind. With long-term antimicrobial use in a given environment, the bacterial communities will change dramatically, with more resistant organisms increasing in proportion. This can result in a situation where the next time an antimicrobial is needed, it may not be effective to treat what was once an easily treatable infection. Mechanisms of antimicrobial resistance. Susceptible bacteria can acquire resistance to antimicrobials by either genetic mutation or by accepting antimicrobial resistant genes from other bacteria. This usually occurs through one of several biochemical mechanisms: mutation, destruction or inactivation, and efflux. Mutation. Mutation is a change in the DNA that can sometimes cause a change in the gene product, which is the target of the antimicrobial. When a susceptible bacterium comes into contact with a therapeutic concentration of antimicrobials like fluoroquinolones, the antimicrobial can bind to specific enzymes, in this case DNA gyrase. The DNA gyrase is an essential bacterial enzyme required for DNA replication. The end result is that fluoroquinolones block bacterial DNA replication, leading to cell death. However, when spontaneous mutations occur in specific areas of the genes encoding these enzymes, antimicrobials no longer bind efficiently. This allows the bacterium to continue DNA replication. Destruction or inactivation. Many bacteria possess genes which produce enzymes that chemically degrade or deactivate the antimicrobial, rendering them ineffective against the bacterium. Here, the antimicrobial is either degraded or modified by enzymatic activity before it can reach the target site and damage the bacterial cell. Efflux. Certain bacteria can often become resistant to antimicrobials through a mechanism known as efflux. An efflux pump is essentially a channel that actively exports antimicrobial and other compounds out of the cell. The antimicrobial enters the bacterium through a channel termed a porin, and then is pumped back out of the bacterium by the efflux pump. By actively pumping out antimicrobials, the efflux pumps prevent the intracellular accumulation necessary to exert their lethal activity inside the cell. Genetic transfer. Genetic material can be transferred between bacteria by several means: most often by conjugation, transformation, and transduction. Conjugation. Conjugation is mediated by a particular kind of circular DNA called a plasmid, which replicates independently of the chromosome. Many plasmids carry genes that confer resistance to antimicrobials. When two cells are in close proximity to each other, a hollow bridge-like structure, known as a pilus, forms between two cells. This allows a copy of the plasmid, as it is duplicated, to be transferred from one bacterium to another. This enables a susceptible bacteria to acquire resistance to a particular antimicrobial agent. Transformation. During this process, genes are transferred from one bacterium to another as naked DNA. When cells die and break apart, DNA can be released into the surrounding environment. Other bacteria in close proximity can scavenge this free-floating DNA and incorporate it into their own DNA. This DNA may contain advantageous genes, such as antimicrobial resistant genes, and benefit the recipient cell. Transduction. In this process, bacterial DNA is transferred from one bacterium to another inside a virus that infects bacteria. These viruses are called bacteriophages or phage. When a phage infects a bacterium, it essentially takes over the bacteria's genetic processes to produce more phage. During this process, bacterial DNA may inadvertently be incorporated into the new phage DNA. Upon bacterial death and lysis, or breaking apart, these new phage go on to infect other bacteria. This brings along genes from the previously infected bacterium.
Fortunately, if we take this threat seriously and muster our intelligence and will to fight back against drug-resistant disease, we can conquer this threat. The rapid diagnosis of childhood meningitis, sepsis, or even antibiotic resistance will soon be available in real time. There is great potential to identify infections faster, treat patients better, and save patient admissions to the hospital, resulting in cost savings to the healthcare system. She was talking about Cepheid's GeneXpert system, which at the time was just poised to enter the market thanks to a U.S. Army contract to detect anthrax. The magic behind the GeneXpert is a Nobel Prize-winning process known as polymerase chain reaction, which allows the GeneXpert to identify if pre-specified strands of DNA are present in a biological sample. What this means is that samples can be placed directly into the machine, which can then tell you in about an hour what disease the patient has and whether that disease is drug resistant. In the United States, the first big application of the GeneXpert was MRSA, a nasty hospital-acquired staph infection resistant to the drug methicillin. More recently, the GeneXpert has made news with its tuberculosis test, which identifies whether a patient has TB and whether their disease is resistant to the drug rifampin. This TB application alone has led to the deployment of the GeneXpert in dozens of developing countries and spurred public health authorities, together with the Gates Foundation, to subsidize molecular TB diagnosis to the point that it now costs less than $10 to diagnose TB quickly and accurately. As Cepheid touts on its website, the GeneXpert system returns most test results in about an hour, including sample prep. With the GeneXpert technology, labs no longer need rows of equipment and extensively trained staff to access molecular testing. To briefly summarize all this, molecular diagnosis can make it possible to determine which drugs are most effective to treat any given patient in a matter of hours at a cost as low as $10 per test in some cases. Once doctors can tell which patients are infected by drug-resistant disease, they can treat these patients with different drugs, or isolate them from others, or take still further steps to limit the transmissibility of their disease. This puts resistant bacteria at a disadvantage relative to their competition, bacteria that are susceptible to drug treatment, leaving only these easily treated susceptible bacteria for mankind to contend with. What's the ultimate message? Although we may never be able to rid ourselves of bacterial disease, we can potentially rid ourselves of drug resistance. Taking such steps now to reverse the rising tide of drug-resistant bacteria would be a wonderful gift to leave future generations, don't you think? The disease would trigger a violent immune response that literally consumes the body from within. As far back as 460 BC, Hippocrates identified tuberculosis as the most widespread disease of his time. Far from prescribing treatment, however, the namesake of the Hippocratic Oath warned fellow doctors not to visit TB patients in the late stages of their disease, lest these doctors' professional reputations be damaged upon their patients' likely death. You see, until the 1940s, there was no effective treatment for TB. Indeed, society's only answer to the TB scourge was to weed out active TB sufferers from their midst, sending them off to so-called tuberculosis sanatoria, where they would be given as much fresh air as possible, but remain bedbound until their death or return to latency.
Because infections were no longer life-threatening and could be prevented with antibiotics. However, we were warned that the more antibiotics we used, the less effective they would become.
No disease has killed more people in all of human history than tuberculosis. A frighteningly contagious disease, TB infected in the late 19th century more than 80%, yes, 80% of all Americans before their 20th birthday. And we didn't even get the worst of it. Infection rates were closer to 100% throughout Europe and elsewhere around the world, wherever people gathered in close quarters. Most of these infections were latent or asymptomatic, but they could activate at any time, at which point
resistant strains of diseases such as TB and malaria, and too few new treatments are being developed to tackle them.
Just stand with your chin on the ledge there, that's it, your hands on your hips.
Any minute now, this man will know whether it's likely that he has TB.
Is your x-ray here, John?
He's come to the Find and Treat bus run by University College London Hospital. So he's clear, but increasingly the people coming aboard are not. And also growing in numbers are those with multi-drug resistant and extremely drug resistant TB, where the antibiotics are simply not working.
These organisms are almost unmanageable in some cases because people have become resistant to so many of the drugs that are currently available. There's hardly anything left in the therapeutic pipeline to treat them with. Treatment for multi-drug resistant TB lasts a minimum of about 2 years, and for XDR-TB it's an even longer.
The introduction of antibiotics in animal feed has contributed exponentially to the antibiotic resistance crisis in the world today.
40 million prescriptions for antibiotics are issued each year in England. Experts warn this is creating new bacterial infections resistant to treatment.
We are seeing increasingly cases of TB where they have multi-drug resistance and are very difficult to treat. And there could be the possibility that in my old age I go for a hip replacement and get some infection and I can't be treated. That's not a nice future.
Antibiotics only became widely available after the Second World War, giving doctors a new weapon against deadly infections, one of the wonders of modern medicine.
In 1928, Alexander Fleming discovered the first antibiotic, penicillin. This was a revolutionary discovery at the time.
All of us, I'm sure, would rather not think about the horror that diseases like tuberculosis wrought on countless previous generations. But we have to remember, because there's a chance those dark days may return. If the drugs that treat TB lose their effectiveness due to antibiotic resistance, there will be little that we can do to stop it from spreading once again, even in wealthy nations like the United States. Moreover, the threat of antibiotic resistance isn't limited to tuberculosis. Concerns over drug resistance have arisen in recent years for many diseases, everything from gonorrhea to hospital-acquired strains of staph, E. coli, and salmonella.
But now there's growing concern they're being overused, taken for minor illnesses or not taken properly.
It's a development which we're told could return medicine to the Dark Ages. The overuse of antibiotics is leading to an increase in drug resistance.